All right, we are doing some trigonometry here. So all the trigonometry that we're going to be working on is trigonometry is a study of right triangles here. Study of triangles. We're always going to be using 30, 60, 90 triangles or 45, 45, 90 triangles. So we've done them before, but I'm going to just recap what we should know about these already, and then I'll develop a little bit more about what we're doing today. So for a 30, 60, 90 triangle, we should know that 30 degrees is the smallest angle. So always opposite of that is the smallest side. And I want you to label the small side with a 1. Then the hypotenuse, the longest side, which is always opposite the 90 degrees, is always double this. So if that's 1, this would be 2. And then the medium side, which is always opposite the medium angle, 60, is a 1 square root 3. So we have to just know these and where they belong, but we're going to be using these 1, 2, and square root 3 over and over and over again. Note again that 1 is the smallest value, square root 3 is the medium, and 2 would be the longest. And you should know which side is opposite which angle then. So 30 is the smallest angle, opposite is 1. 60 is the medium angle, opposite square root 3, and then the hypotenuse is 2. For a 45, 45, 90, this is an isosceles triangle. Let's call this side, we like to call this side 1 and 1. They're the same since it's isosceles. To get the hypotenuse, it was times that by a radical 2. So make sure we know those, and then let's develop the idea of how we're going to work with trigonometry here. I'll give you one example, and then I'll let you try, and we'll go through the notes. So the idea would be, let's say I was doing sine of 240 degrees, and my goal is to solve for that value. What I'm looking for then is, this is the angle is 240 degrees. The answer is a ratio of the sides, the opposite over the hypotenuse. So obviously, I think you know it, but SOHCAHTOA is going to be important today if you can't remember which is sine, cosine, tangent. So our goal for the answer is to find the opposite over the hypotenuse side. So that's a ratio of sides. So if you're wondering what do our answers represent, it's a ratio of sides. So here's how we would solve this one at sine 240. Well, first of all, you might be wondering, how could an angle of a triangle be 240 degrees if the triangle, any triangle, adds up to 180? Well, what we need to do is draw on an XY axis and find where 240 degrees would be located. So first of all, this is always the initial side right here. This is where the angle starts. This would be 0 degrees right here. So you face this way, and then we move in a counterclockwise direction around in a circular motion. And if I complete one circle, I've gone 360 degrees. So from here, starting to here, that would be 90. Continuing on would be 180. And to here would be 270. And at the end would be 360, or back to the start. I can continue going past 360, but all it will do is just continue me spinning around the circle a second time, third time, or fourth time. So 240, where would that 240 be? Well, again, this is 0 is the initial side. 240 would be somewhere past 180 into the third quadrant. This is quadrant 1, 2, 3, and 4. So I'm somewhere in this quadrant here. And when you draw in that quadrant, I don't care if it's exactly, like, you don't have to make it exactly where 240 would be, but it's just in that quadrant. You're going to draw your angle. So 240 went from here to here, 240 degrees. Now, I'm going to make this into a triangle by drawing the right angle always on the x-axis. So this 90-degree box is always going to be on the x-axis. And here's a triangle, a right triangle. This right triangle is always going to be one of these two triangles, either a 30, 60, 90 or a 45, 45, 90 every time. So we need to figure out which one it is. We need to know the angle right at the origin right here. So here's how we can find it for this case. So if it's 240 to get to this angle right there, then we know that from here to here, this much would have been 180. This half circle would have been 180. So how much more did I have to move from 180 to get to 240? So that I can just kind of in my head find the difference between the 240 and the 180 was an extra, I had to go an extra 60 degrees right there. So this angle is very important. It's called the reference angle. So 60 is our reference angle. And this is 90, this is 30 right here then, 30, 60, 90, but I don't want to use this angle ever. So I don't even want to write it, it doesn't matter. The reference angle is always the one we need, which is the angle at the origin of the, touching the origin, right at the x and y axis meet point. Okay, so if that's a 60 right there, now we're gonna label the sides just like I labeled the sides up here with 1, 2, rad 3 on the 30, 60, 90. So here's what I know is that opposite of 60 goes a rad 3. And then here's where the 30 was. Opposite of that would be 1. And then the hypotenuse would be 2. Okay, so hopefully you can just know those are the same things we've always used, same numbers we've always used. We just have to put them in the right spot. Now, here's the deal. To get to that point, think of it, it's like an XY axis here. So to get to this coordinate here, I had to move over in the X direction 1 unit this way. So that would be 1. But I move in a negative X direction. This is a negative 1. And then this going down would be down in a Y direction. Oh, let me put negative 1 right here. I should have said earlier. That's very important. The negative 1 here is a negative 1 here. And then this is the Y direction going up and down, but this time to get to this point right here, I'd have to go down in the Y direction. So it should be a negative square root 3. So you do have to watch on your triangle. If you're going in a negative X direction, put a negative there. If you got a negative Y direction going down, then it's a negative Y. So what about the hypotenuse that's a value of 2? Is that positive or is that negative? The hypotenuse is always positive because it is representing the radius of a circle, like this big circle right here. So a radius of a circle is always a positive. So any problem, these are always positive hypotenuses. All right, so let's get the answer to the problem. Our goal of the problem was to find sine of 240. It was to find the opposite over the hypotenuse. So to do that, sine 240, we don't use 240, we use the reference angle right here. That represents where 240 would be. So for 240, you find the sine of that, sine of this reference angle is the opposite negative square root 3 over the hypotenuse, 2, positive 2. And this is the answer to my problem. Go ahead and try now some of these examples below on your notes, and I'll have all the videos there for you to watch how to do it in case you have any questions.